Yes, we get superpowers. Yes, we get superpowers.
MimbleWimble!
Yes, we get superpowers. Yes, we.
Hello Crypto Gang! Welcome to another LamboLife video. MimbleWimble is where Harry Potter meets crypto. Blockstream's Andrew Polstra said it could replace Bitcoin, and they say it's more scalable and private. That's bold, so this is what I'll do. I'll dice up Mimble protocol and assess how valuable it really is. I'll compare it to similar technologies as well. Let's begin. It all began when an anonymous cryptographer by the name of Tom Elvis Jedusor showed up at the Bitcoin Research Channel. This name is actually French for Tom Riddle, which was the real name of Lord Voldemort in the Harry Potter series. Now, he posted a link to a white paper called MimbleWimble. At first, nobody noticed it, but as soon as they read it, they realized this was a really big deal. This cryptographic protocol that was left by a ghost had the potential to revolutionize the way Bitcoin works. There's some Harry Potter trivia in the white paper. Apparently we have a fanboy here. MimbleWimble is actually a spell that ties the target's tongue, robbing him of his ability to speak clearly. Hence the source of people's misconception that MimbleWimble is mainly just a privacy protocol. But that's not exactly right. It is primarily a scaling solution and secondarily a privacy solution. That's because the scaling benefit is greater than the privacy benefit in MimbleWimble's case. So how does MimbleWimble scale? First of all, there's different ways of scaling. Let's explore them first. The blockchain conceptually looks like this: a series of blocks that represents a history of transactions. Bitcoin plans to scale by offloading most of its transactions off-chain with its second layer, the Lightning Network. In my opinion, this is the most potent scaling solution and is by and large above any others. Unfortunately, today it is still unstable and might have a long way to go before it's ready for mass adoption. Bitcoin Cash, on the other hand, has an immediate solution by increasing the block size. But there's also a third option, which is to compress the transaction data. That's what MimbleWimble does. Instead of making a bigger block, it makes the contents inside smaller. You see, BTC has increased its block size before, but the community has agreed that doing this forever is catastrophic. Why? Take a look at this graph. The rate of increase of Bitcoin's blockchain is not linear, it's exponential. Currently, we have about 200,000 megabytes or 200 gigs, which is the amount of hard drive space you need to set up your own full node, provided that your hardware has enough bandwidth support and computing power. As time goes by and history unfolds, storing this history becomes more and more demanding, as the memory necessary to store the data in each block also needs to increase, as well as the computing power needed to validate them. If all we do is increase the block size perpetually, we are essentially preventing the average guy from being able to run a full node because of the high costs required to set it up, and as a result, allow mining cartels and monopolies to have a lot of influence, hurting decentralization. Bitcoin Cash is doing this block size increase a little conservatively, but Bitcoin SV went all out, which is absolutely insane. Now, what's interesting with MimbleWimble is that it allows Bitcoin's transaction history to be compacted and quickly validated with average computing hardware even after many years of chain operation. The result? A faster and more scalable blockchain. You could literally start up a full node on your smartphone and almost instantly synchronize your full node to the blockchain. MimbleWimble's privacy features are derived from different cryptographic innovations. For simplicity's sake, I'll only include the major parts. First is confidential transactions. This allows the senders to encrypt the amount of crypto they want to send using what you call blinding factors. Again, for simplicity, blinding factors are simply random numbers that mess up the inputs and outputs and make it look confusing for an outside observer. So in this scenario, only the sender and receiver are aware of the amount. However, third parties can still ensure that the transaction is valid by comparing the number of inputs and outputs. But as far as they can see, it's just uniform random things went in and uniform random things went out. And if both inputs and outputs are the same, then the transaction is valid. This procedure ensures that no bitcoins have been created from nothing. But this is not enough. There is the possibility of an omniscient observer, someone who has the resources to do a graph analysis of Mimble's transaction history. Think CIA or a Chinese hacker army. In that case, they could still uncover some information you don't want them to know. Lucky for us, Mimble also leverages another cryptographic innovation called CoinJoin. CoinJoin is a mechanism by which transactions sent by multiple spenders are combined to form a single transaction. Now, because of this, it's difficult for an outsider to determine which payment was intended for whom, adding even more confusion and misdirection. So now you might be wondering, how do we ensure that no one is cheating? What type of consensus model does Mimble have? Well, it is quite different from Bitcoin's consensus mechanism. You see, with Bitcoin's proof of work algorithm, it's more complex. The whole blockchain must be downloaded. The history of transaction outputs have to be analyzed, all to ensure validity. This takes up a lot of time, and it is quite hard to scale, hence the need for a second layer solution like Lightning. But with Mimble, there's a simpler way to preserve the integrity of the system. MimbleWimble blocks only consist of a list of inputs, a list of outputs, and signature data. This offers significant space savings in blocks because other transaction data no longer need to be stored, only inputs and outputs. And by subtracting the total inputs from the total outputs, that is to say, ensuring that the difference is zero, the blockchain is validated because no new coins were created out of thin air. With innovation, there's always things that need to be improved on. Otherwise, there wouldn't be any progress. MimbleWimble has one of the best privacy features, but it's not really perfect. Even with all its privacy, Mimble is not 100% anonymous. There's still the very small chance that some whale or multi-million-dollar organization can override your anonymity should they desperately want to. But it's not something that's really expected to happen often or ever, really. You see, the privacy and scalability aspects of Mimble are intertwined. The more it can scale, the more users it can handle. And the more users, the stronger the privacy. We've already established that confidential transactions are not enough, and CoinJoin needs more transaction volume to be effective. With low transaction volume, it's not too difficult to bypass CoinJoin's privacy. I'll use Assassin's Creed as an analogy here so it's more fun. In the AC franchise, the assassins have three main principles, which are 1. Stay your blade from the flesh of the innocent, 2. Never compromise the Brotherhood, and 3. Hide in plain sight, which is what we'll focus on. What this essentially means is that, as an assassin, one should know how to blend in the crowd, to become anonymous. The key word here is crowd. If you want to be hidden, you have to get lost. You can't be the only person in a field wearing a hood. That's not helping you in any way. The Templars will freaking kill you. Scaling drives privacy in almost every technology. Simply put, the bigger the crowd, the easier to get lost. And that applies especially to MimbleWimble. After all, it is one of Bitcoin's scaling solution. Unfortunately, it's not quite there yet. This has something to do with what you call range proofs. Range proofs are present in all cryptocurrencies with confidential transactions such as Monero or Zcash. It's not just Mimble. Range proofs are important because it prevents the blockchain from having negative outputs. You don't want a negative Bitcoin or a negative Monero. So this range proof is necessary for MimbleWimble to work correctly. But range proofs are also hefty to verify, at least for today. They're working on it, obviously, but reducing the time frame for verification as well as the size of these range proofs is something that they need to deal with before Mimble could reach a level where users can easily run a full node on their smartphone. It's called Bulletproofs, but we're not gonna discuss that right now. Also, MimbleWimble does not support scripting. Scripting is implemented in Bitcoin and it's very handy. It allows advanced features such as multi-signature, secure cross-chain trading, high-frequency trading, and many other complex stuff. But Mimble has really advanced crypto magic to work around this. Many smart contracts in Bitcoin that require a script can be achieved using the properties of what we call elliptic curve cryptography. It's not and probably never gonna be as good as having a Bitcoin script though. Also, you can't simply merge the Mimble protocol with Bitcoin. It's not really an exact fit, but you can implement it as a sidechain or make a new implementation. MimbleWimble is a protocol just like Bitcoin. Now, Bitcoin has two main implementations: Bitcoin Core for BTC and Bitcoin ABC for Bitcoin Cash. Both use the same protocol, but they are different implementations. Mimble has two implementations called Grin and Beam. Both went live sometime in January. The primary difference between Grin and Beam is their general community or governance approach. Beam's governance model is more company-like structured, while Grin is more of an open-source community with members independently working on the project through donations. I'm closely keeping an eye on both, but I still don't think any of this is a replacement for Bitcoin. They are their own thing. Damn, it feels good to be in crypto. That's it for today's video. Thanks for watching. I'm so glad to finally upload this. It took quite a while to fully grasp how it works. Hopefully my time was worth it and you learned something from me. If you enjoyed it, be sure to like, and if you haven't already, subscribe. See you on the flip side.